Now we look at example 3. A conical water tank filled with water has a radius of RCM at the top and HCM high. A. If the height of the water is twice the radius, show that this is the volume. B. Water flow in the tank at the rate of 15 cm cube per second. How fast is the radius changing when the radius is 4 cm? So before we start answer this question, you have to remember that this is the conical water tank. So next, the important part here, if the height of the water tank is twice the radius. For question B, you have to know that this is 15 cm cube per second. Find the radius changing when the radius is 4 cm. So this is the keyword or the key point here. So next, we start to answer this question. Let's say, so we have A. If the height of the water, so first you have to know the volume. So the volume for a cone is 1/3 pi r squared h. This is the volume of the cone. So now we look at question A. If the height of the water is twice the radius, which means that h is equals to 2r. So what the question request here is, show that the volume is equals to 2/3 pi r cube. So from this volume, I'm going to substitute the h with 2r. So next, 1/3 times 2, I can write as 2/3 pi r squared times r is r cube. So this is the answer for question A. Now we look at question B. So here is the question B. Water flow in the tank at the rate of 15 cm cube per second. Again, you can refer to this one. Cm cube means that dV over dt is equals to 15 cm cube per second. Now the question, how fast is the radius changing? Radius. So radius is dr over dt. When the radius is 4 cm. Like the previous example, we start from the question. So dr over dt. Again, I separate into two, dr here, and here is dt. So what I'm going to substitute here is, we just refer to the information that we have. We have the volume. So here is dV, here is dV. And the value for dV over dt, we already have the value, which is 15. So next, we just concentrate in this one. So V with respect to R, or R with respect to V. So next, I know that we're going to use the volume. So volume, the volume that we have here is 2/3 pi r cube. If I try to differentiate this volume, so here we have dV over dr. Multiply 3, or bring 3 to the front. So 2/3 times 3 is 2 pi r squared. So this is dV over dr. So again, let's say, try to highlight for this part. From what we have here, dr over dt. So therefore, dr over dt is equals to dr over dv. So what I have here is dv over dr. So what I'm going to do is 1 over 2 pi r squared multiply with dv over dt, which is 15. So from here is 15 over 2 pi r squared. So finally, when r is equals to 4, dr over dt will be equals to 15 over 2 pi. Our radius is 4, so it's 4 squared. So here is 15 over 4 squared is 16. Multiply with 2 is 32 pi. So since this is radius, so the unit is going to become cm. So cm centimeter per second. So this will be our answer.